Okay, today what we're going to do, we're going to do picoCTF, buffer overflow 3. That's in the hard category for binary exploitation, which is right here. So you can see I've already solved it, so I'm just going to walk through it here. Let's start instance. Okay. And we're not going to look at the source. We're just going to grab the program, the binary. There we go. All right, and say goodbye to it for now. There we go. All right, here's all right there. Booting up WSL. All right, so first thing I'm going to do is I'm going to try and run it. It says, please create a canary.txt file. Okay, I do that. No, canary.txt. 1, 2, 3, 4. Let's just put 4 A's in there. Okay, so now we have that. Try and run it again. Let's do, oops. Okay, interesting. So it's probably got something to do with flag. As usual, I'm going to go ahead and just create a flag here as well. Array. Okay. Now we have a canary.txt file, a flag.txt, and the vuln. And so now we're going to take a look at some of the vuln, check sec on the vuln. Okay. It says no canary found, but we do know that this buffer overflow 3 is all about the canary, and we just created a text file for the canary. All right, so now we're doing object dump just to scope it out. All right, here's our main right here. Okay, and here's a function here, read canary, and then the vulnerable function here. Here's a vuln. Okay. Here's the read canary. Probably just here, yeah, that's open on the file we created. Okay, and then here's the usual win function that we usually get with these picos. And just like in the past, I like to pay attention, especially to the compares. So here's a compare here. Not many other compares. So if I had to guess, I'm thinking that just because this compare in the past hasn't mattered that much as far as any kind of parameters that need to be set or anything like that. It's always been down here where the comparisons lie. And so with this, I'm guessing that as long as we enter into the win function at this address, we'll be golden. And so as usual, do target, something like that. Okay. I don't see any other important functions. Just the usual suspects up there. But right now we have read canary, vuln, main, and win that we need to pay attention to. All right, I'm going to go ahead and jump into GDB on vuln. Break main. And then I've created some things for this. So as we can see, if I disassemble main right now, you see this is mostly, this is all 32-bit stuff. And so I actually have defined two different commands for GDB for these things. Kind of a like I've seen people use GDB GEF and GDB Peta and things like that. However, it kind of throws way too much stuff at me visually, and I'd rather create my own command for those. And so I have one called NX, and what that does is 64-bit wise says, hey, give me 50 things from the stack, and give me the next 8 instructions from the instruction pointer, and then execute next instruction. The other one that I created is NXE, basically for 32-bit. And so instead of 50 GX on the stack, I want 100 words in hexadecimal from the stack. And the stack is going to be ESP instead of RSP, 8 instructions from the EIP next instruction. And so I'm going to run. We've broken at that breakpoint at main. I'm going to NXE because if I try an NX, it's going to yell at me. All right, we're coming up onto some push instructions. As we've seen in the past with buffer overflow 2, we know that we're going to see a 0 pop up. There it is. We're going to see a 2 pop up next and push those zeros to the right. There it is, etc., etc. Keep on going. Okay, so here's some different instructions. We have the read canary, and then we have the vol. The read canary, so if I had to guess, I put 4 A's inside of that text file. And we saw when we disassembled the read canary or the object of it, let me disassemble it now. Let's take a look at it. Okay. See how it has F open? That's why I'm thinking that this canary function is going to perform an open on that file that we created, canary.txt, and it's going to get the values from that file, and that's going to be the canary. And so we're going to see if we spot 4 lowercase a hitting up the stack, which won't be lowercase a's, they'll be x61, I think. So we'll continue on. So now it's in the read canary. I'm not going to go inside the read canary. I'm just going to see what the effects are after the read canary executes, but I am going to step inside the bowl. So I'm going to SI into bowl. Now we are inside bowl. So we're going to, oh, and let's scroll up. So we are inside bowl, but let's scroll up back to where we were because I want to always know this address. We are going to go inside vuln. When vuln comes back, it wants to come back to EIP equal 9622. We don't want that to happen. We want it to go to our target. So, boom, old return. Old return address is going to be 9622. This is what we're going to look at to overwrite with the overflow in the 9336. So here, let's see again. Oh, well, there it is. Yeah. So as you can see, once we got into volume, 9622 was pushed onto the stack. Let's keep on going. It's about to print something to the screen for us. How many bytes will you write into the buffer? There was a jump that this occurred. There's a comparison being made. It pushes to the stack. And then a read is coming up. And so it asks us how many bytes do you want to do. So here I just executed the read function, and I'm going to say well, 8. Let's do 8 bytes. So another jump just occurred. The jump jumped backward. And so I'm looking at this. Whenever you're looking at assembly code, all know that if you come through assembly code and you come across a compare and then a jump, and the jump is forward, then you can pretty much be certain that that's an if statement in the code. If the jump jumps backward, you're looking at more of a for loop or a while. So that jumped backward. And it's calling that read again. Okay, let's see here. Okay, well, I'm going to do, I've already told it 8 bytes, so I'm going to give it 1, 2, 3, 4, 5, 6, 7 Ks. Undefined command. Okay, so 1, 2, 3, 4, 5, 6, but I gave it 7. It took one of my Ks. Okay, so interesting. I'm going to keep going. Okay, jump backward again. It's reading again. 1, 2, 3, 4, 5, 6, 7. Okay, it only took one. And look here, 6 Bravo, that's a K. Okay, so let's keep going, and we're going to keep our eyes on this location right here. Oh, it's already changed. Yeah, okay. So here's that next K. Okay, I wonder what this is. This is 38. Let's see here. Okay, hexadecimal 38 is the number 8. And so what it's done is it's taken how many bytes do you want to input? And I said 8. And then it's taking my input, looks like byte by byte. Let's see here. So we do the once again. I'm going to put a breakpoint. And this breakpoint, I'm going to put on vuln plus 80 right before we call that read. All right. I already know it's going to only take one, so I'm going to just put in one, and then I'm going to continue, so it'll stop at that breakpoint. And yes, it did. And so now I'm going to next. All right, another K. And then next up. Okay. So yeah, as we can see, it's coming across from this stat point here going down. And we know that we need to overwrite this return address. And so I need to calculate how much I need to place onto the stack to get from here all the way to here. And then looking also for the canary. Okay, so this is the canary. This is the canary because a lowercase alpha in hexadecimal is 61. I put 4 alphas into that text file. Here's the 461 all lined up. And so what these canaries are made for is if this value changes, then it will check for that change, and if change occurs, it kicks you out. And so you don't get to overflow the buffer to the location of where you need to go. And so here, what we're going to have to do is we're going to have to overflow all the way up to here and then clone the canary. We're going to have to clone the canary to make it match what it's expecting. And then it doesn't matter too much what we do here. I prefer to keep things very similar. Honestly, you don't even know how big the canary might be. The canary might be, 4 here, but then 8 on the server, or 32-bit canary somewhere else, or 32 bytes rather somewhere else. So, all right. So what we're going to do is we're going to draft. Let's see here. 1, 2, 3, 4, 5, 6, blah blah blah. 2. Let me do some the math here. Okay, times what? 1, 2, plus 4, plus 5, 1, 2, 3, 4, 5, 6, 7, and then plus 2 more of those. All right, something around, let's say about 64 or so. So K times 64K. Yeah, there we go. So payload's going to look something similar to this. This will be the overflow here. So overflow equals about 64K to get from here to here. Let's see here. Okay, I recounted. It's actually 128. There's 128 bytes between this area right here and this area right here. However, we have that 3/8, which is the 8 that we input. And so we're going to drop it down to the overflow being about 127 Ks to overflow this thing. So the unfortunate piece here, though, is as I'm going through, and as you've seen, this keeps on looping. And it's only going to take one character at a time. And so instead of my breakpoint being within the loop, which is going to be a nightmare to try and do, I'm going to set my breakpoint to something more advantageous. And so I'm going to go ahead and disable vol, and I'm going to scope out better location for the breakpoint. So here is all the loop stuff. Let's see here. Completely out of any kind of jump backwards. And also, I'd rather land on something that's not so complicated, not so complex. So instead of landing somewhere where it's doing some major move operation, or even see this function call here, instead of going and landing on a function call, I'm going to go ahead and land somewhere maybe after all the read garbage, but also right before that with like memory copy. I'm going to choose to land at this 210. All right, so breakpoint. I'm going to go ahead and delete all breakpoints because I've already got some breaks inside that loop. So break all of them, yes, and then break main, and then break home plus 210. There we go. All right, so now I'm going to go ahead and rerun the program, yes, and I'm going to continue from, it's in main. I can do NFC and know exactly where I'm at. Good, and then continue. All right, how many bytes will you write into the buffer? I'm going to choose the same, just 8. And now it's giving me an input. And now I'm going to take 127 Ks, 127 Ks. And then when I input these and then press enter, it's also going to do a new line. And so it's actually going to be 126 Ks that I'm going to input onto the stack. All right, undefined command. That tells me that I might still be in the loop. Let me take a look at the stack at this point. Okay, so here's where the K's are. Okay, it looks like it's very interesting because before, when we did this, the K's were showing up, all the input was showing up here. Now they're beginning to show up here. And I'm wondering if perhaps some stack mixes occurred between being inside that loop and now being outside of that loop. And so what I'm going to do too also try and figure out, let's see how many Ks it declined to write here. All right, so I put in 126 Ks. It only took, let's see here, 118. Ah, okay, I see. I think that is the counting limit for the loop. If we put 8 into the question of how many bytes will you write into the buffer, then that creates the I less than 8 or whatever, do this read loop 8 times. And so in order for this overflow to work, I'm going to have to up how many bytes that we're asking it to read into. And then also I'm going to take note, here's the 8 bytes here. I'm going to take note of this new stack that we're looking at because this is not 127 to the goal. This is much lower to the goal. And so I'm going to go ahead and make some counts here offline because I'm a bad mathematician person. Okay, I did the math. Yeah, it's just count these 1, 2, 3, 4, blah, blah, blah. That's 16 times 4Ks, and that's 64. All right. So instead of 127 Ks, we're going to go with the overflow being 64 Ks. And also, we're going to have to make sure that this question here, we set this loop counter from 8 to whatever our payload is, plus maybe a little bit extra. And so right off the bat, I'm going to look at this stack and I'm going to say, okay, we know we need 64 Ks here. Then we need 4 bytes for the canary. And then this is that return address from earlier. And so that return address, this is going to be where our target goes. And so I'll go ahead and say canary here, P32, 61616161 for now. And then we got some filler coming up. So filler 1, P32. I'm just going to copy and paste this thing. Okay, 2, 3, 4, 2. Yeah, target. So target's going to be this now. P32. All right. So at the moment, this is what our payload is beginning to look like. Payload equals overflow plus canary plus filler 1, filler 2, 3, and filler 4. And then our target. There we go. So I'm going to go ahead and begin to write the program that we're going to need. So I think it's like from import all P, actually IP file. Then let's see. Okay, I went ahead and did all the boring stuff. Boring stuff being basically what I like to call the prologue, and then you have the epilogue down here. Everything in between these two areas are kind of the guts. And as we've seen in buffer overflow 2, you can also do a remote thing against the server, which we'll do here in a little bit later. But for now, we're going to, what I would like to call brute forcing it is getting everything from the server instance onto your local machine so that you can be a little bit faster on testing this stuff out. But here's our payload so far, 64 with the canary, supposed canary here, target here, and not changing anything in between just in case. And so let's see here. Now what we have to determine is what prompts are we going to see that we need to take note of. And so I'm going to go ahead and exit out of GDB at the moment. Yes. And run vol. Okay, so this right here is the prompt. And so what I'm going to do is take note of this prompt. There's a new line here that's going to come in right here. And then I'm going to say p dot send line after you see this. All right. And what I want to send to these guys, so this is where we set our counter. We see that we're going to be sending 64 bytes here, followed by 4 bytes, 4 bytes, 4 bytes, 4 bytes. And so we don't want the loop to cut before we've sent everything we need to send them. And so let's see here. 1, 2, 3, 4, 5, 6. 6 times 4 plus 64, 88. And so I'm going to put 88 right here. And so when it says how many bytes will you write in the buffer, we're going to go 88 bytes. And then we should be able to pump in as many Ks as we want without it freaking out about it. And so go ahead and actually try that real quick. This is like 100 and something Ks, I think. Okay, yeah, stack smashing. Okay, good. Okay, good that it's reading the canary. Okay, so let's see here. It sends another prompt. And so this next prompt, we're going to actually send the payload on the next prompt. P dot send line after, sure. And the next prompt, all it is just input right here. So copy bytes, send the payload. Here's let's see how things are working at the moment. Python solution. Okay. The line after. So it's complaining about this thing right here. Okay, I'm an idiot, but so is Python. It should have warned me that I misspelled this function. So, and then also this. All right, so now this should do something better than, well, maybe this all. Okay, perfect. So far, here's the flag. So far, this is working. And it's working in the way that we imagined it to. And so we've given plenty of space for the counter to take in all of the payload. Here we can see with debugging. So in buffer overflow 2, we had context log level. I don't think we had debug. In this one, we have debug set. And so we can see a whole lot more details here. So here we can see all of our Ks coming through, and then the quad As, and then we cloned everything between there, and then there is the target set, and apparently the target set worked, and so hooray. All right, so now we know that as long as we have the canary correct, we're golden. The tricky thing about this particular Pico, the thing that makes this difficult, is that we're going to have to figure out what the canary is from their server. And so we go back, binary exploitation, buffer overflow free, launch instance. Wow, for that. Boom. Yeah. Netcat, uh, ADH, war, a whole bunch of Ks and things like that. As we can see, it's the exact same program, nothing to worry about as far as changing the prompts and things like that. All we need to do, because there's a few ways to do that. You can leak that canary, depending on the situation. In this case, we are going to brute force the canary. The canary, I know for a fact that the canary is only 4 bytes long. And so if we know that the canary is 4 bytes in length, then we know that all we're going to have to do is we're going to have our payload of like 64 Ks. And then in the past, our canary that we wrote was 1, 2, 3, 4. And you're thinking, okay, so we're going to have to come up with a for loop that brute forces and tries every possible scenario for these characters. And the answer is actually yes. But it's not going to be so lengthy that it's impossible, especially when it's just 4 bytes. And so we know that for 4 bytes, we need to do a for loop through every possible combination that could exist for a byte. And so if you remember, if you don't remember, just go to ChatGPT, ask a quick question. Hurry up. I hate AI. All right. How many possible bytes exist? Go. Crap. Hold on. Okay, you can just Google it. AI sucks. I hate AI. Anyway, it's how many possible bytes exist? It's 256 possible bytes, just so you know. And those options are X00 all the way to X0FF. And these bytes, you will not be able to see them print out to the screen in a human readable form as we go through this brute force. But just know that we are, for each of the 4 bytes that we're going to target, it's going to be about I in 256 or so different options for each location of these bytes. Okay, so the first thing that I'm going to do is I'm going to take this canary that we've got set hardline here. I'm going to put it up here. It's not going to be the age, it's going to be the empty string starting out because we don't know exactly what the canary is currently, and we want to build the canary as we brute force. And so you can do something like this with context.flat, because whenever you're attacking the server, you kind of want a little bit of feedback from the program saying, hey, I'm still working. I'm still going through the processes because sometimes this takes a while and you don't want to be just stuck there on something that's not even working. But what I like to do instead of like with context uh, showing me on the screen, I like to do with context on quiet. So and then put all of the things that I want to see and print them out as it goes. So kind of make my own context as it goes. So here we go with for loop for at in range. So here's the outer loop. It's going to be from 1 to 5. And that's for the 4 byte locations of the canary. And then the inner loop for Y in range of 156 possible bytes, and that's from like 00 to FF for each little bit. All right, the next. And so here, we want to go ahead and connect to the remote server while we're doing this. So P remote, and then the server name and the port number. And so just for right now, let me go into here. I'm just going to grab this for now. This will change. We have 8 minutes to get this thing done. I'll restart the server here in a little bit, but for right now, I'm going to put this stuff right here. So, boom. There we go. Perfect. Okay, and we're going to go ahead and grab this because once we connect to the server, we're going to get that prompt and we're going to send that prompt response back to the system. Let's see here. And actually, we're going to go ahead and do something different than hard coding 88 toward it. We're going to go ahead and send it 64 plus f dot encode. Okay, and the reason we're going to do this The reason we're going to do this is because here we're targeting the position at which the canary byte exists that we want to affect. And so if we have the canary, and it was something like 61, 61, 61, 61 in the hard code stuff, these are now question marks, 1, 2, 3, 4, but they're question marks that begin after a case. And so we have our overflow here, the K's times 64, and then our canary comes in directly after it. And so it's like K's and then 1, 2, 3, 4, or 1, 2, 3, 4. And so what we're doing is we're saying, hey, uh, here I want you to target the 65th bit. And then after you target the 65th bit, I want you to, or byte, excuse me, I want you to target the 66th byte. And then I want you to target the 67th byte to get this canary solved. And so that's what we're going to do. And so the next line, the line after, K times 64 plus the canary that we're building plus the character at Y, in code. And then because I have with context dot quiet, go ahead and keep kind of a printer going to make sure that I'm printing out my own statuses. And so here, canary, so far. Now, all got, and then here, so as it goes through each loop, I'm going to get responses. And we already know that one of those responses we've already checked is stack smashing detected. We can choose really anything that's very unique in any in this entire string that comes back at us. And so something that's very unique that doesn't exist in the other prompts is the word smashing, could be call up, could be detected, whatever string you want. We'll do we'll do if rough, not in out, then I want you to go ahead and build that canary with that character at that location that did not give us the string for us. And then I want you to print the canary as it exists at that time. And then if everything goes well, go ahead and break out the loop. And so hopefully this entire piece right here brute forces the canary for us. Once the canary is brute forced, then we want to go ahead and create a new instance of our solution. So remote, because as you can see, this every time this thing enters the loop, it attacks that server once again. There's a new instance of the server, new instance of the server. So we'll do a remote, copy paste. There we go. All right, and overflow is good to go. And I need to add that prompt again. We can just hard code the 86 on this piece. So boom, 88 rather. All right, so how many bytes? That's 88. Here's your overflow. And keep the fillers and keep the target. The canary's coming in to this part of the code as a string. Whereas, as you can see, the overflow is in bytes, filler bytes, target bytes. So we need to actually do a little encode option here on the piece. So encode. And so now we have the string that we get from all this stuff. And we're saying, hey, put it into bytes before you add it into this. Otherwise, we'll get an error that's like, cannot concat a string to bytes. And so, payload. Okay. So yeah, I think this thing is ready to go. I'll go ahead and restart the Pico server. All we need to change the support address. So copy and put here. All right, let's see if that's going to work now. Nope, not right here. In Ranger, another dumb mistake by me. No problem. Solve, save. All right, try it again. Okay, that's ugly. Get rid of debug as well. As a matter of fact, you don't need any of this stuff if we're attacking a server. So, all right, save that. There we go. Okay. It's going a whole lot slower than I want it to go. So here, once it gets the first bit of the canary, I'll go ahead and pause the video. Okay, so there's the first bit of the canary. Canary so far is capital B. And I'll go ahead and pause while it gets a little bit further in. Okay, it's about to come across the second part. There's the second part of the canary. We have that. Now it's starting over at the beginning of that loop again. Okay, should be hitting the next piece. There it is. All right, canary so far is BIR. Okay, there it is. So once it gathered the entire canary, which in this instance is a bird, that's when it goes through the rest of the code here. And as you can see, the Pico flag turns out to be static, something, something, something. Flag. Okay, correct. And so that's how you do buffer overflow 3.